So, hello everyone, my name is Hariom Raghuvanshi, and today I am going to walk you through the backend architecture, design, and the technology and implementation of payment integration system. Mm, And I build using Spring Boot microservices architecture. This project is built entirely in Java using Spring Boot and Spring JDBC REST API and various industrial tools and mm, and practices like Maven and others. So the system has three microservices. The first is the payment validation service, and it validates payment requests. And the second is the payment processing service. It handles business logic and the workflow. And the third is the Trustly mock service simulates third party like any Trustly, any PSP, like any payment permit provider. They're integrated with the this service. Each of these services is independently deployable and communicates over REST APIs. So, so let me start by explaining the architecture. So in this system we have the architecture is a service microservice based, and each component is loosely coupled and independently deployable by using microservices and also API driven. So by use of API driven, all communication is through REST API using JSON payloads and mm, stateless communication. So each request is treated independently, and the another is internal internal communication. So each request, sorry. REST points with standard. So REST point with standardized status and headers. Then another is the security. So for security, HMAC 256 for secure P purpose for the secure message passing and observability. Like we want to observe our code, like how data is how data is going and our code working properly or not. For that we integrated log4j and also slf4j and and we have the service one, which is the payment validation service. So this is the first service in the flow which accepts payment request and performs format validation and field integrity check. And in that the and in that the Spring Boot and Spring Web, Lombok, Log4j for logging and custom exception handling is used. And and the second is the payment processing. So in this like in the payment processing, this is the core business service. It performs uh, it basically have the core business logic, and it is that many things are happen, and that the Spring Boot and Spring JDBC is used, and also then we have Trustly Mock. So this is integrated with the NEPSP. So for uh, and we also tested the endpoints using the Postman, and and uh, mm, response validation and error scenario testing was done via Postman collection, and the and the Trustly Mock service simulates a third-party payment gateway. It helps in testing and to-end payment flows, and by working on this project, I have learned many things like about Eclipse IDE, about Maven, about Bitbucket and Git and Sonar and Post, and also understand what is uh, AWS EC2, and also have some knowledge about the mm, ActiveMQ. So for performance and scalability, so to ensure good performance, Redis was added to catch frequent access data, and asynchronous operations blend with ActiveMQ, and the microservices are scalable due to stateless design. So and some key challenges I have faced, like design to contact API between services, and securing internal API with HMAC, and handling error propagation and traceability, and writing integration tests that I learned a lot about real world service interaction and API contracts, secure backend practices, how build a scalable backend system. So I built a payment system with full backend logic validation and mock interaction. so mm, so I have also learned about something while working on this project. So I have learned about microservices. So microservices is a architectural style. So microservice architecture is an approach to software development where the application is structured as a collection of small and loosely coupled independently deployable services. Each services corresponds to a specific business functionality. So why we use microservice? So for because it is independently deployable, and we also does scaling on that, and also fault isolation, technology flexibility, and faster deployment, and faster delivery cycle. For example, in our payment deal system, I have broken down the system into three microservices: payment validation, payment processing, and trust level. So each service run independently and communicate using REST APIs. Then I also learned about Spring Boot. So what is Spring Boot? So Spring Boot is built on top of Spring framework. It simplifies the configuration and the setup of Spring application by providing production ready default things and auto configuring beans and using embedded server like Tomcat and eliminating boilerplate XML config. And in my project, I use Spring Boot for three services, which helped me to set up and test endpoint quickly with the embedded Tomcat. And I have also learned about what is RESTful RESTful APIs. Okay, sorry, RESTful APIs. So so REST means representational state transfer is a set of architectural principle for designing a network application. So REST APIs use standard HTTP methods like get, post, put, delete. So some features of RESTful API is it is stateless, like no session stored in server, and JSON format is widely used. Like you want to send data or any receive it, so well, it does on JSON format and easy to test using, and it is also easy to test using tools like Postman. And so in our project, all communication between services is through REST APIs. And is another thing I have learned about the Maven. So Maven, what is Maven? So a build automation tool used for managing dependency and compiling and packaging code, like generating jar files and running unit tests. So in my project, all services use pom.xml file to handle dependency, like Spring Boot starter and Lombok and another. And I also learned about the Bitbucket. Sorry, Bitbucket. So what is it also? Mm, so it is basically a version control, and Bitbucket we use it for pushing code, managing commit, and handle issue using Git. So basically, we will deploy our code on Bitbucket. Like it is like as a GitHub. It is the another tool. So then I also know about something like Eclipse IDE. Eclipse. Okay. So it's basically a IDE widely used for developing project in Java, and it is used for writing and running code, and it also provides many features like we can internally install Lombok in it, and also generate getter setter, and also it provides many things internally. And and I also learn about logging. So what is logging? So logging so logging is used for tracking our code. So for that we used the Log4j. So Log4j is used for logging important event and file. So then also I also learned about the HMAC SHA 256. So It is it is a hash-based message authentication for secure API communication. It's basically for the security purpose, and I also learned about the what is about JSON and Lombok and Sonar. So, so basically, JSON is basically for converting Java object to JSON or JSON to Java object, and the Lombok, what Lombok? Lombok reduces boilerplate code by using annotations like at the rate getter, at the rate setter, like that. So by using these annotations, we have no need to create getter and setter. And the sonar is basically used for used for code quality checks and static analysis, like what is good for our code he suggested. And so I have built a payment integration system using Spring Boot microservices, which validate transaction via payment validation service and processes them using payment processing service and simulates third-party integration using Trustly mock service. So all services communicates using REST APIs and follow microservice architecture. So the system is scalable, testable, and production ready, leveraging modern tool and best practices. Thank you so much.